t dt, explain the meaning of your answer in terms of water flow using correct units. Hopefully I have a nice set of 6 intervals. Right? 1, 2, 3, 4, 5, 6. Okay. So the first interval is 4 units. Are they all 4 units? That's nice because then I can do this and save myself some time, right? And then I'm going to do 9.6 plus 10.3. Then 10.3 plus 10.9. Then 10.9 plus 11.1. 11.1 plus 10.9. 10.9 plus 10.5. 10.5 plus 9.6. Does that cover it all? Tell me that for me. 253.5. Units? Gallons. 5 gallons. Good. Gallons per hour times hours if we're talking about areas. So gallons. What does that mean? That many gallons flowed out of the pipe in 24 hours, right? And I'm going to be a little more specific on that and say, I'm going to say in this 24-hour period. Is there some time between 0 and 24 such that r prime of t is 0? Why? Good, Rolle's theorem, right? R of 8 and R of 16. Why did I pick those? They have the same y value. What do I need to state for Rolle's theorem? That part. And use Rolle's theorem. What has to happen? It's different. Rolle's theorem is just a special case of mean value, so you could even use mean value if you wanted to. Mean value is wonderful. Since the function is continuous and differentiable, how do I know that? Tells me it's differentiable, and differentiability implies continuity, right? So R is continuous and differentiable. You don't really have to say why if you wanted to. You can say it says differentiability implies continuity. You do have to say you know that it is continuous and differentiable. I am using Rolle's theorem. However, mean value theorem would work great. Side note, instead of writing that for mean value theorem, you would say R of 16 minus R of 8 over 16 minus 8 is 0. Okay, so that would be the difference if you use mean value versus Rolle's. Rolle's only works if it's 0. Mean value works broader scale. So if you didn't know Rolle's, that's okay. Use mean value. Therefore, by mean value theorem, R prime equals 0 at some C, or therefore by Rolle's, R prime of C equals 0 by Rolle's theorem. So either way, first grade. Questions about that? Okay. Today we're going to look at the second part of the fundamental theorem. The part that's useful. I gotta get that part useful too. Really. Okay, if you will follow with me. This is a proof of the second part of the fundamental theorem. When you get to Cal 2, they may call the first part the second part, the second part the first part. It's really just one theorem. So don't get too caught up in part 1, part 2, right? So all the fundamental theorem. Okay, so if we have capital F be an indefinite integral of f, okay, better word for that is capital F is an antiderivative, right? So you asked me the other day, someone asked me, what does the capital F mean? Well, there's your answer. Usually capitals stand for antiderivative. So if you have a capital F of x, that's the antiderivative of little f of x. This is the heart of the fundamental theorem that we talked about yesterday. If we have a function that equals that integral, there is a function c such that capital F of x equals a of x plus c. So what that's saying is that if a is the actual function, we could add c to that and get the antiderivative. Those only differ by a constant is what that says. Substituting a in for x, we could do the integral from a to a, right? What's the integral from a to a? 0. So we would get 0 plus c, which is c. Property of integrals, we got that. So then, if I put in a b instead of a c, the antiderivative at b would be the integral from a to b. I kind of wish they hadn't thrown in the a function, but that's okay. The integral from a to b of f of t dt plus c would be the integral from a to b of f of t dt plus f of a. Hold on, we're getting somewhere. I didn't say it was kindergarten. Okay, and they're showing you this function just with the plus c. Okay, then they're showing you the f of a equaling the f of a part. Therefore, rearranging some things. This is the important part. You didn't have to write any of that down. With some algebra, you get the capital F of b minus capital F of a is the integral from a to b of f of t dt. What that means for you is I can find the antiderivative at the top number and subtract the antiderivative at the bottom number and get the exact area. That's what we need to know.
So there's no point in doing that with part that we've been doing?
Well, it's the antiderivative. So, how do you find the exact value of the area underneath the curve? You do the antiderivative at b minus the antiderivative at a. Notice this notation is a little different than the other notation. They called the number in the, or the function in the integral f prime. And so what's the antiderivative of f prime? Just f. So you could use this notation or you could use the capital F, either way, depending on what you want to do. So this is big. Because how did we have to find the area under sine of x before this?
Yeah, boxes.
Yeah, and to get accurate, how many boxes would you have to do? A lot. All of them. It's a problem, right? You can imagine Isaac Newton getting tired of boxes, right? And so he's thinking there's got to be a better way. Well, this is the better way. So, how are we going to do it? Okay. So write that down and we'll do, then we will find the area under sine of x exactly with very little work. It's the same. It's really the same. It's called part 2 in this textbook that I got this out of. In some textbooks they don't break them up. one that you learned yesterday. And technically, there's not really two parts.
I didn't know there was one of the versions. It's like, oh, there's 7 versions.
Number 6.
This is not very intuitive, right? Doesn't just come to you. Like your job is like, oh, this would help me find area, right?
If you explain it in,
Yes. To find the area, the exact area from A to B, you find the answer and plug in B, and then you find the answer and plug in A, and that gives you the exact area. Only if you couldn't integrate it. Only if you remember yesterday we said not everything is integrable. Yes. So there's some things you might not be able to find the integral of, and that's when you would stop.
okay, so
They aren't on this one. Everyone listen to this really quick. On the first one I have it capitalized, but on this one I don't. Someone explain to me why. This says F prime here. You see how that says F prime? So just regular F would be the antiderivative. But if a different book may write this differently and they may call this F, and then I'd have to use a different notation here because I'd have to get the antiderivative, so that's what it capitalized. This is actually a combo of you got the PDF and you got the F prime.
What's antiderivative?
Well, yes.
Okay, I understand that you have to like backtrack to get it, but what is it? Like, why are we finding it?
Undoing the derivative.
So it's the original equation.
Right. Now, it's crazy. It's not intuitive. And that helps us find area. That's the thing that Isaac Newton came up with. That he realized, and I showed you that the other day where I just showed you, hey, it's working.
I mean, that's great. As a student, but I'm not kidding.
Well, and the actual proof behind it, like all the way through, is pretty nasty. So you're just going to have to take my word for it today. The antiderivative, when you find the antiderivative of the y value, that's b minus a, it gives you the area. Okay, so let's try it, because I think y'all are freaking out at me, and this is not a hard thing. So let's leave it at be quiet. Alright. So, what is the antiderivative of sine?
Negative cosine.
Negative cosine. Now, it's one problem only. I am going to go ahead and write the plus c, and we'll talk about that in just a second. I'm going to put a little bar here and evaluate this at 0 and at pi. Yes, after you anti-differentiate, we're going to put a bar there, so we're evaluating at 0 and at pi. What do we get when we put in pi? What's cosine of pi? Negative 1, and what's negative 1?
1.
Okay, so I get 1 plus c, whatever that's, right?
Yep.
Minus cosine at 0. What is cosine at 0? 1. So negative something we get negative 1 plus c. When I subtract those, what do I get? 2.
Why are you subtracting them?
That's the point. So it says
Oh, shoot. Okay.
what happens to c?
Or if you cancel it.
They cancel. Will they always cancel?
Yes.
Every time. If you take the same function with a constant and that same function again with the same constant, subtract them, won't the c's always cancel? So, good question. For definite integrals, and you need to write that word down, this is called a definite integral. What we did yesterday was called an indefinite integral, so it didn't have any limits on it. need it. Later we'll talk about that. But if you're just finding areas, these will always cancel. Yes. That's mathematical notation for evaluated at pi and then at 0. So it helps me remember what these were. Why don't I just still write the integers? Because I already did that part. I already anti-differentiated. So that's just a way to say evaluated at 0 and evaluated at pi. It's two notations. To tell you where to evaluate it at. The pi and the 0. Otherwise you lose those. It's just notation. Okay, let's look at the next one. What is the antiderivative of x squared? Good. X cubed over 3, does everyone agree? Plus
6 squared. 2x. Boom.
And again, the notation is I'm going to put a 0 and a 3 there. I'm going to plug in a 3, and I'm going to plug in a 0, and I'm going to subtract. So that's what the formula said to do, the second part of the fundamental here. I think y'all are overcomplicating this. Relax. Don't take a break. Okay. I think this is why angular speed and linear speed were hard for you last year. I can't talk. That's the problem. You don't let me finish. If you would let me finish, this would be easy. It hurts a little bit. Alright, 3 to 0. So I'm going to plug in 3. So 27 divided by 3 plus 6, right? Minus 0 plugged in gives me. So I get 9 plus 6, which is. Now the 3, the f of b comes first and then the f of b. Really quick, I want to show you what we've just done. Get your calculator out. Go to your RIE program and do one of these in your RIE program. Doesn't matter how many n's you put, does it? Look at the final thing that has the exact integral value. Are we getting the same thing? There is a faster way to type that in your calculator. By the way, it's alpha. Where's the derivative button? It's in the same place. There's the button by your derivative button. You'll want to find it. The integral button. Here, let's look at the next one. Any questions so far? We see how to do it now? Yeah. Don't freak out. Okay. It's not a bad thing. These Any questions about this one? Is it making sense now? No? Do you see how to do it? Now, as far as where it came from, that's tough. Right? That's why it took until a couple hundred years ago to come up with this stuff. It gives you areas. This one's a tough one. This one is a challenging one. Find the value of k. The integral from 0 to k of 1/4 x cubed dx is 16. X cubed, or 1/4 x cubed. Okay, what do I do first? Okay, rewrite the integral as an antiderivative from 0 to k. So if it's x cubed, what did x cubed come from? X to the 4th, and then what do you do with that exponent? Divide by it. So it's already 1/4, and you divide by 4 again, you get 1/16 x to the 4th. From 0 to k. If I were to work this out, I would get 1/16 k to the 4th minus 0. Is that right? And what does that equal? Can I find k? 16 times 16. Then you're going to end up 4th rooting it, so you can just leave it as 16 times 16 if you want to. 4. K equals 4.
That way we do the minus.
Yes, and so it was k plugged in and then 0 plugged in. Read the next one. See if you can come up with anything on the next one. Last night's homework go okay? The region bounded by the x-axis, part of the graph coast of that, between negative pi over 2 and pi over 2 is separated into two regions by the line x equals k. If the area of the region from negative 2 pi k is 3 times the area from pi over 2, then what is k? So this is a real AP problem. So, are there any ideas? You might want to draw a picture. Might help. So I have cosine of x from negative pi over 2 to pi over 2. is 3/4 of the area. What is K? Find area. I like that. Find the whole area first. Not agree? Okay, well, what is the whole area? How would we do that? The integral from so the integral from negative pi over 2 to pi over 2 of cosine of x. What's the antiderivative of cosine of x? From negative pi over 2 to pi over 2. What is the sine of pi over 2? 1. What is the sine of negative pi over 2? So what is 1 minus negative 1? So the whole area is 2 units. So what's the area of that little piece from k to pi over 2? So what? The big one would be 1. Okay, good. So the little one would be a half. How'd you get that? Divided by 4, multiplied by 4, however you want to do that. So does everyone know how I get that that little piece is a half? Or you could talk about the big piece being 1 1/2. Either way, that means that the integral from k to pi over 2 of cosine of x dx equals 1/2. Does that look like a problem we just worked just a second ago? So this is sine of x from k to pi over 2. I know the sine of x is, or sine of pi over 2 is 1 minus sine of k equals a half. Subtract 1 from both sides, I get negative 1/2 equals negative sine, or sine equals a half. Do I know when sine equals a half? When? Pi over 6, which C is the 30-degree angle, which is C. So that one was a tough one. It was a lot of work. There are some like that on the AP exam, some that are even open response like that. Okay, find the area of the shaded region. How am I going to find the area of the shaded region? And I'm just going to set it up. Because we integral of the square root of x from 0 to 1 plus. Good. That's how you would find that area. Makes sense? Two separate integrals under two different curves. Okay. Write this down. Finish your worksheet and do these odds on page 320. What do you know about odds?